Hello and greetings to everyone. We will continue with 10x, which is cube roots. If, for example, we are given a number m and we are required to look for the cube root of m, it is simply that number n such that when you multiply n by itself 3 times, the result will be m. In this case, we are going to say n is the cube root of m. Let's start by writing down these few examples. If you take, for example, -1 times -1 times -1, it is simply equal to -1. We know -1 times -1 gives us +1. +1 times -1 is equal to -1. And if we take 1 times 1 times 1, it is equal to 1. If we take this other example, -2 times -2 times -2, -2 times -2 gives us +4. +4 times -2 gives us -8. And we take 2 times 2 times 2 is equal to 8. You can see the results are different. Here it is negative, positive, negative, positive. If you take -3 times -3 times -3, -3 times -3 gives us +9. +9 times -3 gives us -27. And if we take 3 times 3 times 3, it gives us +27, and so on. So you take note, in this case, it is not like in the case of square root where you multiply a negative number by itself. The result will be the same as multiplying the positive of that number by itself. Now let's write this down. We say -1 is the cube root. -1 is the cube root of -1, because if you multiply -1 by itself 3 times, you obtain -1, comma 1 is the cube root. 1 is the cube root of 1. You can see 1 times 1 times 1 gives us 1. -2 is the cube root of -8. 2 is the cube root of 8. -3 is the cube root of -27, and 3 is the cube root of 27. Now let's write this down. For n belonging to the set of integers, we say that n is the cube root of m if, I'll write it down with the right pen, if m is equal to n times n times n. So we write this down as, write this down as, this is how we write it, the cube root of m is equal to n, where this symbol, our v, which looks like a v with a 3 above, as such, The symbol is called the cube root sign. So when you see this symbol above any number, that means you are looking for the cube root of that number. Now let's take a hyphen by the margin. We can also find the cube root of a number by prime factorization. So we can use prime factorization to find the cube root of a number. Let's take this example. Find the cube root. Find the cube root of 64. The solution. First, we need to prime factorize the number 64. You know 64 is equal to 2 times 32, which is the same as 2 times 2 times 16. It is the same as 2 times 2 times 2 times 8. Let's continue here by the side, which is equal to 2 times 2 times 2 times 2 times 4. It's equal to 2 times 2 times 2 times 2. 4 is the same as 2 times 2. Next, now for us to get the cube root of the number 64, we are going to group the prime factors, the product of the prime factors in groups of 3. And they should be the same in every group. The prime factors should be the same. Here we have 1, 2, 3. This is the first group, we group it. 1, 2, 3. For the second group, we group it. Here in the first group, we are going to extract the prime factor 2. In the second group, we extract the prime factor 2. Now, for us to get our cube root, we are simply going to multiply the prime factors extracted from each of the groups of 3. In this case, our cube root of 64 will simply be equal to 2 times 2, because we have just 2 groups of 3, which is simply equal to 4. So this is our result. You can verify. It simply means we multiply 4 by 4 by 4. 4 times 4 gives us 16. 16 times 4 gives us 64, which goes back to this. So that means 4 is the cube root of 64. Now we note this down. Take note. The cube root of a number, the cube root of a number is positive if the number is a positive number. If the number is a positive number. And the cube root of a number is negative if the number is a negative number. So you take note of this. The cube root of a number is either positive or negative. So it depends on whether the given number is a positive number or a negative number. Now let's take a hyphen by the margin to find the cube root. To find the cube root of a number in index form, we simply divide the power or powers, it depends on how many prime factors we have, by 3. That is, if we are to calculate the cube root of a number as such, e to the power n times b to the power m is simply equal to a to the power n divided by 3 times b to the power m divided by 3. So this will simply be equal to a raised to the power n over 3 times b raised to the power m over 3 as such. Now let's take an example on this. Take example. Right, find the cube root. Find the cube root of 2 raised to the power 3 times 3 raised to the power 6 times 3 times 5 raised to the power 9. Take down solution. You need the cube root of this our number in index form, 2 raised to the power 3 times 3 raised to the power 6 times 5 raised to the power 9. So this will simply be equal to, we are going to divide the powers by 3. This will give us 2 raised to the power 3 divided by 3 times 3 raised to the power 6 divided by 3 times 5 raised to the power 9 divided by 3. So this will simply be equal to 3 divided by 3 gives us 1. 2 raised to the power 1 times 3 raised to the power 6 divided by 3 gives us 2 times 5 raised to the power 9 divided by 3 gives us 3. This will simply be equal to 2. 2 raised to the power 1 remains 2 times 3 raised to the power 2 times 5 raised to the power 3. So this will be the final answer. Take now the next hyphen to find the cube root of a fraction, precisely a vulgar fraction. We find the cube root of the numerator and the denominator separately. That is, we have to find the cube root of a fraction of a vulgar fraction a over b. This will simply be equal to the cube root of a all over the cube root of b. That's what it means. Now let's take an example on this. Example. Find the cube root of 27 over 64. We take solution. You take note, it is the cube root of this entire fraction. Because most often at times you see students writing something like this. In such a case, you write something like this, that means it is the cube root of 27 on 64, which is not true. So you take note, you must extend the root sign, this sharp pointed end of the root sign, for it to cover the denominator of the fraction. So now we know the cube root of 27 over 64 is the same as the cube root of 27 all over the cube root of 64. Now we need to find the cube root of 27 and the cube root of 64. So if you take 27, let's do the prime factorization of 27. You know 27 here, we can write it as 3 times 9, which is the same as 3 times 3 times 3. So we group the product of the prime factors in groups of 3. So you're just going to have one group, which is 3 times 3 times 3. This group we are going to extract 3. That means the cube root of 27 will simply be equal to 3. Now for 64, in the prime factorization of 64, you know this is the size 2 times 32, which is the size 2 times 2 times 16, which is the size 2 times 2 times 2 times 8, which is the size 2 times 2 times 2 times 2 times 4, which is the size 2 times 2 times 2 times 2 times 2 times 2. So we are going to group them in groups of 3. Here we have 2, 2. The cube root of 64 is simply equal to 2 times 2, which is equal to 4. Now, it's very easy for us to get the cube root of the fraction 27 over 64. So the cube root of the fraction 27 over 64 will simply be equal to, we know the cube root of 27 is 3 all over the cube root of 64 is 4. So this is our answer. It simply means if you take 3/4 times 3/4 times 3/4, the answer will be 27 over 64. Let's verify. This will be size 3 times 3 times 3 at the numerator, or 4 times 4 times 4. 3 times 3 gives us 9. 9 times 3, 27. 4 times 4 gives us 16. 16 times 4 gives us 64. And we are done with this example. Now let's end by taking this exercise of application. Let me correct the exercises. Exercises for application. Goes find the cube roots of the following For A, we have the number 125. For B, we have the number 2744. For C, we have the number 21,952. For D, we have the number 3 raised to the power 12 times 5 raised to the power 6 times 7 raised to the power 3. And for E, we have the number 27 times 64 all over 125. F, we have the number 2 raised to the power 9 times 3 raised to the power 3 times 5 raised to the power 6 all over 3 raised to the power 12 times 6 raised to the power 3. We are going to take solution. For question A, we have the number 125. We are going to make use of the method of prime factorization. We know 125 is divisible by the prime factor 5 since it ends with the digit 5. We know 125 divided by 5 gives us 25. Give us 5 times 25. It should be equal to 5 times 25 is the same as 5 times 5. We're going to group it in 3. Then we are going to extract just 5 here. Therefore, the cube root of the number 125 is simply equal to 5. We are done with question E. Next, now we go to the next question, question B. For B, we have the number 2744. We need to prime factorize the number 2744. We know this will simply be equal to, we can divide 2744 by 2. It gives us 2 times 1372. This will simply be equal to 2 times, we know we can divide 1372 by 2. 2 times 686. This will give us 2 times 2 times 686 divided by 2 gives us 343. This will give us 2 times 2 times 2 times, we know 343 is not divisible by 2 and it is not divisible by 3 too. The number 343 is divisible by 7. If you divide 343 by 7, it gives 49. This will give us 7 times 49. This will simply be equal to 2 times 2 times 2 times 7. We know 49 is equal to 7 times 7. So we are going to group the product of these prime factors in groups of 3, in which in each of the groups there, the prime factors are the same. So here we are going to extract 2. Here we are going to extract 7. Therefore, the cube root of the number 2744 simply be equal to 2 times 7. And 2 times 7 is simply equal to 14. So this is the answer. Go now to question C. For C, we have the number 21,952. We need to start by prime factorizing this number. Now, if you divide this number by 2, we are simply going to obtain 10,976. So this will give us 2 times 10,976. We can still divide 10,976 by 2. This will give us 2 times 2 times 5,488. We can divide 5,488 by 2. This will give us 2 times 2 times 2 times 2,744. Next, now you can divide the number 2,744 by 2. This will give us 2 times 2 times 2 times 2 times 1,372. So this will simply be equal to 2 times 2 times 2 times 2 times, you can divide 1,372 by 2, which will give us 1, 2, 3, 4 times 2 times 686. So this will simply be equal to 2 times 2 times 2 times 2 times 2 times 2 times 686 divided by 2 gives us 343. This will simply be equal to 2 times 2 times 2 times 2 times 2 times 2 times 343 here is divisible by 7. So this will give us 7 times 49, which is equal to 2 times 2 times 2 times 2 times 2 times 2 times 7. We know 49 is this as 7 times 7. Next thing, now we are going to group the prime factors in groups of 3. Here, this is the first group, 1. This is the second group, 2. And this is the third group. So here we are going to extract 2. Here we extract 2. Here we extract 7. Therefore, the cube root of 21,952 is simply equal to 2 times 2 times 7, which is simply equal to, we know 2 times 2 gives us 4. 4 times 7 is equal to 20. And this is the result. We go now to question D. We have for 3 raised to the power 12 times 5 raised to the power 6 times 7 raised to the power 9. We need the cube root of this. In this case, we are simply going to divide the powers by 3. So this will simply be equal to 3 raised to the power 12 divided by 3 times 5 raised to the power 6 divided by 3 times 7 raised to the power 9 divided by 3. This will simply be equal to 3 raised to the power 12 divided by 3 gives us 4 times 5 raised to the power 6 divided by 3 gives us 2 times 7 raised to the power 9 divided by 3 gives us 3. This will simply be the answer. We go now to question E. For E, we have to find the cube root of 27 times 64 all over 125. So we need the cube root of this entire fraction. 27 times 64 all over 125. We know this will simply be the same as the cube root, the numerator, which is 27 times 64 all over the cube root of 125. This will simply be equal to the numerator here. We can break it as such: the cube root of 27 times the cube root of 64 all over the cube root of 125. So this will simply be equal to, we know the cube root of 27 is simply equal to 3 times the cube root of 64, which is simply equal to 4, all over the cube root of 125, which is simply equal to 5. So this will simply give us 3 times 4, which is 12, all over 5. So our answer will simply just be 12 on 5. This is the result. We go now to the last question, question F. We have to find the cube root of 2 raised to the power 9 times 3 raised to the power 3 times 5 raised to the power 6 all over 3 raised to the power 12 times 6 raised to the power 3. We need the cube root of this entire fraction. Times 3 raised to the power 3 times 5 raised to the power 6 over 3 raised to the power 12 times 6 raised to the power 3. So this will simply be equal to, we are going to divide the powers at the numerator by 3 and the powers at the denominator by 3. This will give us 2 raised to the power 9 divided by 3 times 3 raised to the power 3 divided by 3 times 5 raised to the power 6 divided by 3 all over 3 raised to the power 12 divided by 3 times 6 raised to the power 3 divided by 3. So this will simply be equal to 2 raised to the power 9 divided by 3 gives us 3 times 3 raised to the power 3 divided by 3 gives us 1 times 5 raised to the power 6 divided by 3 gives us 2 all over 3 raised to the power 12 divided by 3 gives us 4 times 6 raised to the power 3 divided by 3 gives us 1. So this will simply be equal to 2 raised to the power 3 times 3 raised to the power 1 simply remains 3 times 5 raised to the power 2 as such all over 3 raised to the power 4 times 6. 6 raised to the power 1 simply remains 6. You can further simplify. 3 will go here 1 time, 3 will go into 6 here 2 times. So now we can apply the laws of powers. Remember, we saw that if we are to divide two numbers in index form as such, a to the power n divided by e to the power m is simply equal to e raised to the power n minus m. So we are going to apply our knowledge here, our knowledge of powers. This will simply be equal to, here we have 2 raised to the power 3, and at the denominator we have 2 here, which is raised to the power 1. So this will simply give us 2 raised to the power 3 minus 1 times 5 raised to the power 2 all over 3 raised to the power 4. 3 raised to the power 4 at the denominator will stay. 2 will disappear. So this will simply be equal to 2 raised to the power 3 minus 2 gives us 3 minus 1 gives us 2 times 5 raised to the power 2 all over 3 raised to the power 4. So this will be our final answer. And we are done with the solution of the exercise for application. If in case you have any questions, make sure you leave them at the comment section. Thank you very much for watching.